Okay, our next parallelogram that we're going to talk about is a rhombus. And a rhombus also goes into the category of a parallelogram. So when we look at this tree diagram, we know that we're studying quadrilaterals. That's how we started out. We've already talked about parallelograms. And we know that the parallelograms have these 5 qualities. We know under parallelograms, we talked about a rectangle last time, and the rectangle had 2 additional properties. Remember, we said that the diagonals were congruent in a rectangle and all angles were 90 degrees. Now we're going to talk about another parallelogram, and that's the rhombus. Okay? Now, a rhombus still has all the qualities of parallelogram. That doesn't change. But now we're going to introduce 3 more new properties. Okay, the first one is that all sides are congruent. All sides are congruent. The diagonals, I'm spelling diagonals wrong. D-I-A-G-O-N-A-L-S. The diagonals are perpendicular. And diagonals are angle bisectors. Okay, so those are my 3 new properties. The diagonals are angle bisectors, so it splits this angle in half, splits all those angles in half, and they are 90 degrees, and all sides are equal. So let's take a look at how to solve the missing blanks in the rhombus, but I love this diagram, how everything relates. So get used to seeing that. Okay, let's move down. And of course, you guys, if you always want to start ahead, you're more than welcome. Let's take a look at number 3. Okay, so RT is 22. US is 18. Okay, so let's fill in some blanks here. We know that they diagonals bisect each other. So if this whole length is 18, this is 9 and this is 9. And if this whole length is 22, this is 11 and this is 11. So I'm going to change it up for a second. 11, 11, 9, and 9. And I know that these are all right angles. So if I want to, this is a 9. If I want to find out UT, this is a hypotenuse. So I can do Pythagorean theorem and say 9 squared plus 11 squared equals c squared. So 81 plus 121 equals c squared. And that's going to be 202. So x squared equals 202. And then when I get the square root by itself, it's going to be 14.2. So UT is 14.2, which makes RS 14.2, and ST 14.2, and RU 14.2. So RS is 14.2, ST is 14.2, UV we already said was 9, and VT we already said is 11. So we're going to use Pythagorean theorem there to solve that guy. Jump down to, let's do one more. Okay, let's do number 5. All right, so ZY is 34. So all my sides are 34. I know that WY is 38. So if this whole length is 38, I know that this is going to be 19 and this is going to be 19. And I know that ZXY is going to be 34 degrees. And we know that this is 90 degrees, so that's going to allow us to find that angle measurement there. All right, now let's look at WZ is what I'm trying to find. Well, I know that WZ is going to be 34 because all sides are equal, so that's 34. VY is going to be 19 because the whole diagonal was 38, so that's going to be 19. ZV is this length here, which I need to use Pythagorean theorem to find it out. Now, be careful here because this is a leg. So it's x squared plus 19 squared equals 34 squared. So we got to work this one backwards. So when I do that and I combine everything, I get x squared equals 795. Is that right? 795, yes. And then when I take the square root, I get 28.2. So this length is 28.2. Okay? And my zx, the whole length, is going to be 28.2 times 2, and that's going to give me 56.4. Now let's look at our angle measurements. Now that we did the sides, let's look at angles. I'm going to erase that. I know that this is 90 degrees, and if this is 34, that's 124 together, so that's going to be 56 degrees right there. So WXZ is going to be 90, 90, there are 134, 56. Well, that's going to, oh, they split it in half, duh. They are also angle bisectors, so it splits that in half. So WXZ is going to be 34 degrees. WVZ is 90. They intersect and form 90 degrees. ZYW is going to be 56 degrees as well because it's splitting that angle in half. So that guy's 56 degrees. And then XYW is also 56 degrees. So we just kind of piece that in there. All right, now we're going to talk about another shape besides the rhombus, and that's a square. So when we look before at the mapping, and I'm just going to write this for your information. So we talked about quadrilaterals. We know that parallelograms are quadrilaterals, and we've gone in detail ad nauseum, those 5 qualities of a parallelogram. Then we branched off the parallelogram, and we talked about a rectangle. And we said a rectangle had 2 properties. All angles are right angles, and diagonals are congruent. And then we just now talked about the rhombus, and we introduced those 3 new properties, that diagonals are angle bisectors, that they are perpendicular to each other, and all sides are equal. Now, we're going to talk about a square. A square is super special because it has all the properties. It has every property of a rhombus, it has every property of a rectangle, and of course it has every property as a parallelogram. So a square fits all the criteria, everything. Opposite sides congruent, parallel, opposite angles are congruent, consecutive angles supplementary, diagonals bisect each other, 4 right angles, diagonals congruent, 4 congruent sides, diagonals perpendicular, and diagonals bisect opposite angles. So it is a rhombus and a rectangle together, and that is what makes the square. So we fill in the information much like we've done every other shape. So we can take a look. Let's just look at we'll look at number 8 and 10 just to get some practice in there. So if you look at number 8, MNOP is a rhombus, so find MP is what I'm looking for. Well, you know these sides are equal, so 9x minus 77 equals 3x plus 7. So when I solve for x, I get 6x equals 84. X then equals 14. I think that's 14 if I did my math right. And then when you plug in 14, 14 times 3 is 42. 42 plus 7 is 49. So all lengths are the same, so it should be 49. MP equals 49. Here we have a square, and SW is 2x plus 13, and UW is 8x minus 41, and we're trying to find VT. Well, we know in a square that diagonals bisect each other. We know that they're congruent to each other because they fit both of them. Oh no, my screen shut off. Hang on. Oh, the technology is great, they say. Let me get back up there. Okay, so if you look at that, how would we figure it out? Well, you know this. We're going to set these equal to each other. 2x plus 13 equals 8x minus 41. When I solve for x, I brought 2 over here to get 6x, bring 41 over here to get 54, and then x, of course, is going to be equal to 9. So when I plug in 9, I get 18 and 13, which is 31. If this is 31, this is 31, this is 31, this is 31. Remember, they're congruent and they bisect. So VT is going to be the whole length, which is 62. So VT is 62. And then we plug in just using the information that we have. So if you need help, extra problems, please, please, please come see me.